All right, welcome everybody. Today we're going to continue on with our exponent unit. We're going to do our lesson 3. But let's just quickly recap our first two lessons. So we've learned 3 exponent rules so far. The first one we learned is that anything raised to the 0 power is just 1, with the exception of 0, right? 0 to the 0 power is undefined. Also, in that first lesson of the unit, we talked about negative exponents. If we have a negative exponent, we have to make it positive. We make it positive by if it's negative in the numerator, we move it to the denominator, then it becomes positive, or vice versa. If it's negative in the denominator, we must move it to the numerator to make it positive. And then finally, our third rule we talked about is multiplying things with the same base. So for instance, if I have like x to the third times x to the fourth, they both have a base of x. We learned in our last lesson that we just go ahead and add our exponents and the base stays the same. So it stays with the base of x. 3 plus 4 give me 7. So let's go ahead and do a little warm-up, kind of incorporating all those rules that we talked about so far. So if you've not had a chance to do the warm-up, make sure the sub pauses the video and gives you a minute or two to give it a shot. All right, let's go ahead and check our answers here. So for the first one, 29 to the 0 power, we know anything raised to the 0 power, that's just 1. That one's really nice and simple to simplify. Looking at the next one, I don't see any exponents of 0. That's perfect. I don't see anything with the same base that I can multiply together, but my issue I see here is I have a negative exponent. Right? The 3 has an exponent of 1, that's positive, so that doesn't have to move. The x has a positive exponent 2, so that also gets to stay. So the 3x squared stays, but we have to move y to the negative fifth. We have to move it to the denominator so that it can become y to the positive fifth. And then last but not least, here it looks like we have a bunch of multiplication to do. And I know we see negative exponents, but let's deal with the negative exponents at the very end. Let's go ahead and do our multiplication. Remember we saw in the last lesson, we want to make sure we multiply those coefficients first. Or in other words, I just like to pull them out to start with. So I'm going to pull out the 4 and the negative 2, right? Knowing I have to multiply those. I'm going to go ahead and multiply things with the same base. So I have x and x to the third. Well, that first x has an exponent of 1, right? That imaginary 1. So it's 1 plus 4 if I add those exponents together, so it gives me x to the fourth. And then I have to deal with my y's. I got y to the second times y to the negative fifth. And again, that rule says, well, my base stays the same. I add my exponents. 2 plus a negative 5 gives me negative 3. Now I can go ahead and just clean things up a little bit. 4 times negative 2, that gives me a negative 8. X to the fourth. Y to the negative third. And then again, hopefully you're seeing another issue, right? We still have a negative exponent. We need all of our exponents to be positive. We do not move the negative 8, right? Because the negative 8, even though the number's negative, the exponent's still positive. We only move things with negative exponents, not if they themselves are negative. So the negative 8 stays, the x to the fourth stays, but that y to the third has to move to the denominator to become positive. And that's what your answer should look like for that third one. So hopefully that was a good review for you of our last couple lessons in this unit. So what we're going to talk about today is we're going to talk about some more multiplication properties of exponents. Here's our objectives. And just like when we did our first round of multiplication properties, remember I had you look at some examples and I had you try to figure out what the rule is. We're going to do the same thing here. So I'm going to stop talking for about 10 seconds here. I want you to look at example 1, 2, and 3 to see if you can figure out what the rule is when we are raising a power to a power. All right, so if we look at these, right, raising a power to a power, meaning I have 4 to the second, raising it to the third power. Hopefully you noticed, right, when we raise a power to a power, it looks like we just multiply those exponents, right? 4 to the second raised raised to the third power is 4 to the 2 times 3, which is 4 to the 6th. Same thing with the next one, power to power. Right? I'm not multiplying two things with the same pace. I'm taking something raised to a power to another power. I have to multiply those. So it'd be f to the 5 times 10, which gives me f to the 50. The last one's a little bit different, right? I mean, it's still that same power to power, so we multiply. So negative 2 times 4 gives me 7 to the negative 8th. Right, we know that we cannot have negative exponents. We want to make them positive. That's why they moved the 7/8 to the denominator to make that a positive exponent. So again, our rule today is if we are raising a power to another power, we have to multiply those exponents. Let's talk about why this works. So if I have 3 to the third raised to the second power, right? If I raise something to the second power, that means I'm multiplying by itself twice. So what this is telling me is I have to take 3 to the third times itself twice. That's what it means to raise it to the second power. Well, if I break it down further, 3 to the third is 3 times itself 3 times. I have another times 3 to the third, so that's another 3 threes. And if I look here and I count, I have 3 times 3 times 3 times 3 times 3 times 3. That's 3 times itself 6 times, which is just 3 to the 6th. And again, I could have gotten that just by multiplying my powers. Power to power, I multiply. One more just to prove that it works, right? Based on the rule, if we raise a power to a power, we know this would be 2 to the 4 times 3, or 2 to the 12. But let's just make sure this works. So first off, I have 2 to the 4th to the third power. So that means I have to take 2 to the 4th times itself 3 times. That's what it means to raise it to the third power. Well, if I break down these 2 to the 4ths, 2 to the 4th means 2 times itself 4 times. So here's the first 2 to the 4th, 4 twos. I got another 2 to the 4th, so that's 4 more 2's. And a third 2 to the 4th, so that's 4 more 2's. Right, if I count up all those 2's, it looks like I have 12. So that's 2 times itself 12 times, or 2 to the 12th. So that's why it works. So our rule for today that we're adding to our list of rules is that whenever we raise a power to a power, right, power to a power, we just go ahead and multiply those exponents. So let's do a couple examples here. So if I have 4 to the second raised to the third power, that's power to power, I have to multiply those exponents. So that's 4 to the 2 times 3, which would give me 4 to the 6th power. Same thing over here. I have d to the third raised to the third power, power to power. The rule is I got to multiply. So this is d to the 3 times 3 power, which would be d to the 9th. Power to power, we just go ahead and multiply our exponents. All right, before we make things a little bit harder, I want you to go ahead and try this slide. So if the sub could at this time, go ahead and pause the video for about a minute here. Let the students try these, and then we will come back together and go over the answers. All right, hopefully you had time to try these. So if I'm looking at the first run, right, power to power, that means I have to multiply my exponents. So you should have gotten t to the 44th power. Excuse me. Looking at the next one. Again, power to power, there's fractions here, but we know, or we should know, right, multiplying fractions, that's pretty easy, right? You just do top times top, bottom times bottom, you just multiply straight across. So when I do that, you should have gotten x, 2 times 1 is 2, again, I'm just going straight across. 3 times 2 gives me 6, so I get 2/6, which you can simplify that fraction. You should have had x to the 1/3, right? 2 and 6, they both divide 2. That's why we can simplify to 1/3. Next one, again, power to power. I'm just throwing some fraction stuff in there, trying to make it a little bit harder for you. So it's just x to the 4th to the 1/2. So you just take x to the 4 times 1/2. Remember, we can make 4 a fraction, put it over 1. Again, you still multiply straight across. 4 times 1 gives me 4. Over 1 times 2 gives me 2. So 4/2 is just simplifies to x squared. Or just think, what's half of 4, right? Half of 4 is 2. Last but not least, another kind of easy one, like maybe the first one, just in the sense that there's no fractions. Again, power to power. We just go ahead and multiply. So I get m to the 20th power. All right, hopefully those ones felt okay. We're now going to amp it up and make them a little bit harder. So let's go ahead and look at the next slide. So here's where we're combining some rules together. Notice I have some multiplying of things with the same base, but I also have raising to a power. So this goes through PEMDAS, right? We have to do the power to power stuff first before we can do any multiplying, right? That's basically, we're multiplying our exponents right before we would go ahead and add them. So that's PEMDAS. So again, we got to deal with the power to power stuff first, the stuff that we dealt with today. So that means I have to, in this first problem, I have to deal with this part. Oops, sorry, I highlighted more than I wanted to. We got to deal with this part first, the power to power. So that means I have to take 5/2 times a negative 2. So that y to the 3rd, that's going to stay for right now. 5/2 times a negative 2, right? Power to power, we multiply. Make that a negative 2 over 1. So it looks like I get y straight across negative 10 over 2, which that simplifies to a negative 5th, right? So I have y to the 3rd times y to the negative 5th. Now I do the rule from yesterday, right? Multiplying things with the same base, right? They both have a base of y. That means we have to add our exponents. So I'm going to sneak that in here. I get y, 3 plus a negative 5 gives me a negative 2, which again, I can't leave it like that. I don't want negative exponents, so I have to bring that to the denominator to make it positive. So there's my final answer. Again, we have to deal with the power to power stuff first. Right, that's just using PEMDAS, doing the multiplication of exponents before we do any adding of exponents. So let's look at the next one. I got x squared times x to the 6th raised to the negative 4th power. Again, we just said we have to do power to power stuff first. So power to power, I have to multiply those so that x squared, that stays as is, but x to the 6th raised to the negative 4th power would be x to the negative 24th power. 6 times negative 4 is negative 24. Now I can go ahead and multiply things with the same base like we did in the last lesson. So that would give me x. I just add my exponents now since I'm multiplying with the same base. So it gives me x to the negative 22nd. Again, we can't end with a negative exponent, so it's right now like in the numerator of this fraction. So I have to bring it downstairs to make it positive. And again, we'd put a 1 in the numerator. 1 in the numerator. All right, let's try maybe just one more here. Let's just do the one on the left. We'll do this one. Again, we're raising powers to powers first. So I have to take care of this 5/3 raised to the 3rd power first, right? So that means we're multiplying here. Again, I can make this a fraction. I can put it over 1, so I can multiply just straight across, right? Multiplying fractions, that's no problem for us, hopefully. So I still have that w to the negative 2nd. Over here, I'd have w. Again, I got to multiply those exponents because it's power to power. So I have 5 times 3, that gives me 15 over 3 times 1, which is 3. I'm going to go ahead and simplify that up a little bit. So 15 over 3 gives me w to the 5th. At this point, I'm almost done. I got to use my rule from yesterday, multiplying things with the same base. Remember we said we just add our exponents. So that gives me w, negative 2 plus 5 to the third. I have a positive exponent here, so I don't have to move it. We are good. We are simplified. So again, the big takeaway is we got to do power to power stuff first. All right, moving on to our next rule. This is our last new rule for today. It's the power of a product property. All right, remember product in math, that means multiplication. So power of a product, meaning we're raising some product, some sort of multiplication to some power. And what that says is if I have something in the parentheses multiplied raised to some power, I can basically just do kind of like the distributive property, right? And I can distribute it to both of those terms. Understanding that I'm still raising a power to a power, so that A technically has an exponent of 1, so does the B. So I have to take m times 1 and m times 1 for the B. Right? So m times 1 is just m, so I have a to the m times b to the m. It's still power to power, so we still have to multiply those exponents. But we know if we can have it in parentheses like that, that multiplication, we can distribute that power on the outside. So just to show you some basic examples here, right, it says negative 6 times 5, and I'm raising it to the second power, meaning I can distribute the second power to the negative 6 and 5. Currently, the negative 6 is raised to the first power, so is the 5. So I'm going to multiply both of those powers by 2. Since 6 is negative, I want to make sure I keep that in parentheses because I want negative 6 raised to this power, not just 6. So I have negative 6 to the 1 times 2 power, which is just 2. And then I still have times 5. And it was originally raised to the first, but I'm distributing that 2 in there, so 1 times 2 gives me 2. So now I can simplify even further here. Negative 6 squared means negative 6 times negative 6. So that's a positive 36 times 5 squared, which is 5 times 5, which is 25. And then we can go ahead and simplify that with our calculators. 36 times 25, I believe that's 900. 900. One more here just to kind of show us the property, and then we'll get into some more advanced examples. Here again, I have this product, right? It's 4 times y times z. I'm raising it to the third power, meaning I get to distribute that third power to the 4, the y, and the z. Right now, 4 is raised to the first power. So again, I take the exponent for 4 times the 3, because it's power to power. 1 times 3 gives me 3. Y to the first to the third power, 1 times 3 gives me 3, so it's y to the third. Same thing with the z, it's raised to the first power, so 1 times 3 gives me z to the third. Again, I can go ahead and simplify here, 4 to the third. Well, that's 4 times 4, which is 16, times another 4, which will give me 64, y to the third, z to the third. No negative exponents, no zero exponents. Nothing with the same base to go ahead and multiply together, so that would be my final answer. So again, power of a power, we go ahead and multiply exponents. And if we have a product, right, we're multiplying some terms in a parentheses raised to a power, we can distribute that power and still use that power to power property. So let's do some slightly harder examples. I know it says your turn, but let's actually try maybe a couple of these together. So again, I have to deal with that power to power stuff first, right? I have this this 7m to the 9th raised to the third power. I have to distribute this third power in first. So I have to distribute it to the 7 and to the m, right? Every term inside the parentheses. Right now, 7 is raised to the first power, right? There's that imaginary 1 there. We know power to power stuff we have to multiply. So this would be 7 raised to the 1 times 3 power, which would be 7 to the third. And then I have m raised to the 9, and I'm distributing that 3 in there. Power to power we have to multiply. So it's 9 times 3. Which if I clean things up, 7 to the third, if you type that into your calculator, you should get 343. Then m, 9 times 3 is 27. Again, we have to distribute to all terms, and it's still power to power, so we have to multiply our exponents. Looking at the middle one, again, I'm going to distribute that -4. It's got to go to the 2 and to the z. It's got to go to every term. Currently, the 2 and the z both have those imaginary exponents of 1. So we'd have 2 to the 1 times -4, so it would be 2 to the -4th. Z to the 1 first power raised to the -4th, so it's 1 times -4, which gives me -4. Again, you cannot stop here. You will not get full points on a quiz or a test because we have negative exponents. So if I look here, it looks like the 2 has a negative exponent and the z, so they both have to move to the denominator of my fraction, right? So I move the 2 downstairs and it becomes a +4 for the exponent. Z also becomes a +4, and I'm left to the first power. Again, I can go ahead and simplify, and I know that 2 to the 4th is going to be 16 z to the 4th. Again, we just have to distribute it in, and it's still power to power. So let's go ahead. We're just going to skip this third one because I want to get into some slightly trickier ones. Let's go ahead and skip down and look at this problem here. So this is kind of what the problems on the homework are going to look like. It kind of incorporates a lot of different, or all of our different rules that we've learned so far. But again, my first thought is always I want to take care of power to power stuff first. So if I'm looking here, the first thing I see is this x to the -2 raised to the second power. So power to power, I have to go ahead and multiply. Right, so I have to multiply that -2 times 2. So that gives me x to the -4th. It looks like over here I have another power to power, right? I'm raising 3x, y to the 5th, to the 4th power. So I got to distribute that 4th power to the 3, to the x, and to the y. So that would become 3. 1 times 4 give me to the 4th. X has the exponent of 1, so again 1 times 4 gives me x to the 4th. And then I'd have y, multiplying those exponents, 5 times 4 gives me 20. So I'm going to go ahead and clean things up a little bit. I first have this 3 to the 4th, which I know I can simplify that, right? So I'm actually going to pull that out front. 3 to the 4th, and I'll simplify that in a second, right? Because that's going to give me a nice number. I can now go ahead and try to multiply things with the same base. Well, here's an x and here's an x. So if we're multiplying with the same base, that tells us we can add our exponents. So -4 plus 4 gives me x to the 0. There's nothing to multiply that y with, nothing else with the base of y, so that just stays y to the 20th. So just to finish this problem off, we see 3 to the 4th. Again, if you type that into your calculator, you would get 81. X to the 0, well, we know anything to the 0 power is just 1. So I'm just going to put a slash to that because that'd be like 81 times 1, which is still going to be 81. And then I still have this y to the 20th. I don't have any negative exponents. I've combined everything or multiplied everything with the same base. So then it looks like I am finished. That's as simplified as we can get it. All right, I want you to go ahead and try a problem. And I know we have 2 left. I want you actually to do this one. Try the one that says optional. So if at this time the sub could go ahead and pause the video, I want everyone to give this one a try. You probably need about a minute to do so. And then we'll come back and we'll talk about it. And then we'll be done with notes for today. All right, so hopefully you had time to try this problem. Again, on this problem, we got to deal with power to power stuff first. So that means I have to raise 6ab to the 3rd power. So I'm going to go ahead and distribute that 3rd power to the 6, the a, and the b. So it would give me 6 to the 3rd, a to the 3rd, and b to the 3rd, right? Because the 6, the a, and the b all have exponents of 1. So 1 times 3 for each of those is just going to give them an exponent of 3. I got to do the same thing with that second parentheses, except now I'm distributing a 2. Again, I have to distribute the 2 to the to the 5 and to the a. It's got to go to both. So currently it's 5 to the 1st. So if I power to power, I multiply. 1 times 2 gives me 5 to the 2nd. And then I'd have a. Negative 3 times 2 would be a to the negative 6th. I'm going to go ahead and pull out just my numbers out front here. So the 6 to the 3rd and the 5 to the 2nd. Six to the 3rd, 5 to the 2nd. Now I'm going to go ahead and multiply things together that have the same base, right? So here's a base of a, another base of a. So if I'm multiplying things with the same base, I get to add my exponents. So 3 plus negative 6 gives me negative 3. And last but not least, right, I have this b that I haven't dealt with yet, but there's no other terms with a base of b, so there's nothing I can multiply it with to simplify it any further, so I'm just going to leave it as b to the 3rd. Again, I think it's helpful. Notice how I'm underlining and I'm circling things just so I make sure I talk about each term and I don't forget something. So now we can clean things up a little bit. 6 to the 3rd is going to give me 216. Again, just plug that into your calculator. Times 5 squared is 25. Got a to the negative 3rd, b to the 3rd. Again, I can keep cleaning things up a little bit. I can go ahead and multiply these two numbers together. All right, so I have to take 216 times 25, and I believe that's going to give me 5,400. Hopefully I typed that in correctly. And I still have the a to the negative 3rd, b to the 3rd. And again, hopefully you're thinking, gosh, you're not quite done yet, right? You can't have negative exponents. Well, the only thing with a negative exponent is the a. Don't move the 5,400 with it, right? Because that's its own term and that's raised to that first power. So the 5,400, that stays. The b to the 3rd also stays. And I have to move that a to the negative 3rd down to the denominator so that it can become a to the 3rd. And those are our notes from today. So again, just to recap, whenever we have power to power stuff, we have to take care of that first. Remember, when you raise a power to a power, you have to multiply your exponents. Once you've done that, you can go ahead and multiply things together that have the same base. Remember, when we multiply with the same base, that's when we get to add our exponents. And then at the very end, if you have negative exponents or exponents that are 0, you have to clean those up, right? Move the negative exponents to either the numerator or denominator, depending on where they are when they start. You have to move it to the opposite side of the fraction. Remember, anything raised to the 0 power is 1. So as always, if you have any questions, make sure you shoot me an email. Otherwise, go ahead and get some good practice in on the worksheet. Thank you, everybody.